Often, to complete the characterization of an RF path, it's required that you terminate the RF path with a good RF termination. In this particular case, we've now tested the feeder cable and the combiner with an open circuit. Typically we would use a short, and now we're going to go into the tag, delete the open, and instead add a load. In this particular case, a load that we're using doesn't list as a tag, so we'll add RF. We're going to use the word termination. We do this because there's also low PIM loads and low PIM and PIM sources, and we don't want to create or confuse those particular issues. So now we see that we've added the RF termination to this test tag string, identifying that we've now got inline a dual band combiner, a feeder cable, and an RF termination. In this particular case, if we want to be completely accurate, we would also add a tag that says high band. Again, keep in mind at all times that the effort using tags is to communicate. So now we go back to the measurement. We've made the setup, so we're going to now resweep the system, and what we'll find for this system is now we're beginning to see an improvement in the return loss of the path, but also for the DTF measurement we're getting values which are much lower as we would expect. We select trace 2, which is the DTF measurement, and use the auto scale to bring the scale up to where we can see more detail. Here again, the max marker is in the same location, and what we find is it's now a max of 26.23. Bear in mind that a DTF is a calculation based on the measurement of the return loss and some mathematical processes. This implies that it is not absolutely accurate with regards to amplitude, but instead is optimized to get the location correct. You also will see in this particular case that we've limited the measurement to just the span of the high pass portion of the filter. So again, we overrode the stimulus. If we wish, we can save the trace for DTF to memory by pressing the M icon. We can then turn off stimulus override or change the frequency range to the full range and retake the measurement to see what variation might occur when we sweep through a band limited device and try to make a calculation of a DTF. Here the calculation is ongoing, and we see a quite different result based on the fact that our filter blocks in the mid-band crossover region all the frequencies. This, for lack of a better term, confuses the measurement and the calculation made by the Fourier transform. So this indicates again the importance of making sure that you're looking at your DTF measurements in a passband of your RF path.